Welcome to NexTechie Qubits The Brief, your weekly lens into the quantum frontier. Let's get rolling.
We're moving past the hype of raw, noisy qubits into an era of reliable, error-corrected systems engineered for real corporate use. Imagine jumping from sputtering experimental airplanes straight into reliable commercial jetliners. So, how do we actually make these machines stable for business? Well, first by decoupling memory from processing. ETH Zurich's new chip architecture stores data as microscopic mechanical vibrations, or phonons, instead of fragile electromagnetic states. It's kind of like a classic CPU RAM split. Your processing qubits do the math, while mechanical resonators provide resilient storage. But once you have stable memory, you gotta make sure the calculations themselves don't break down. Second, we're reaching the error correction threshold. Google's Willow chip hit a below-threshold benchmark, meaning adding more physical hardware actually reduces the error rate. Because of this, Google is funding resource estimation to figure out exactly how many qubits are needed for specific industrial problems. Why does this math matter? Because enterprises won't invest a dime without a clear cost-benefit analysis comparing quantum performance against classical supercomputers. With memory and error correction falling into place, the global market is sinking its watches. Finally, we've got a 19-vendor consensus. Rivals like Quera, IonQ, and IBM have totally dropped their old million-qubit promises. Instead, they're aligning roadmaps to deliver early fault-tolerant machines with 250 to 1,000 logical qubits between 2028 and 2030. It's literally wild seeing competitors ditch vanity metrics for unified engineering milestones. The entire quantum industry has officially shifted from theoretical lab experiments to measurable commercial engineering targets aimed at the end of this decade. The race for quantum advantage isn't just accelerating, it finally has a clear finish line.
This was NexTechie Qubits The Brief, just a brief overview. Upgrade your subscription to access the full newsletter and our detailed explainer video.